Okay, you've just learned about how to name ionic and covalent compounds. And what we have to do now is just the end of the bonding basics. Now, it's mostly related to covalent bonds, which is when electrons are being shared. And this may seem a little bit scattered, but like I said, or like you are taking 2 weeks of information and putting it into one day. So all I'm doing is picking out the most important things from the covalent molecule section that's going to show up on your midterm and presenting it in this presentation. So the first thing, this is called just some bonding basics. The first thing that I'm going to do here, you can see, is put a periodic table. And if we number those numbers right there, now if you remember, take a second and answer this question. Those red numbers represent what? What you should have said is that those red numbers represent the number of valence electrons. So for example, anything in that first group has 1 valence electron, anything in the second has 2, and so on. What's important about that is the Lewis dot structures. Okay. And the Lewis dot structures work like this. What you have to do is, this is such an easy topic. All you have to do is look at the number of valence electrons. So again, if I gave you an example, let's say I picked out silicon, which is element number, it's right here, element number 14. If you were to look at that, you'd say it has 4 valence electrons. So that's all you have to do is look through them and determine how many numbers of valence electrons there are. For this one, we can ignore, again, our transition metals. So I'm going to give you a few examples here. Let's start with hydrogen. That one has 1 valence electron, so it has 1 dot around it. Nitrogen has 5 valence electrons, so it has 5 dots around it. The maximum number of dots that anything can have around it is 8. Now I want to show you how you actually draw one of those out. We want to have electron pairs. That's important in bonding. So if I'm going to do neon, which has 8 valence electrons, to draw it, I put 1 dot. I went a little bit faster than I thought it would there. Let me go back. Neon has 8 valence electrons. So in order to do this, you just put 1 dot around each side. And then if you have more, you continue to pair them. So neon has 8 valence electrons. There's 1, 2, 3, 4, and then I start pairing them. 5, 6, 7, 8. Okay, my next example is sulfur. This one has 6 valence electrons. So again, I put 1 on each side, and then I start pairing them. So I did selenium, also 6 valence electrons. 1, 2, 3, 4, 5, 6. Okay, so notice they're not just randomly scattered there. If it only has, for example, 3, something like boron, you're only going to put 3, so I would just go 1, 2, 3. Okay, now it doesn't matter if I started that. I could also, if I erase that, and I do boron here again, it doesn't matter if I started those dots over here, 1, 2, 3. It doesn't matter, again, as long as they are just evenly spaced until you get more than 4 and you have to start doubling them up. So that's Lewis dot structure. You will have to, on your midterm or on a test that you could take, you will have to recognize a picture of an element's Lewis dot structure. So if you had to do the picture of bromine, which has 7 valence electrons, you'd have to pick the picture that had 7 valence electrons. Next bonding basic is what is called the diatomic elements. Now, for those of you that had me, I always referred to those as the heavenly seven. And what diatomic elements are, if you notice how this is broken down, what the word is broken down into, di stands for two, and then atomic stands for atom. So it's two atoms. And these are the 7 elements that when they're found naturally on Earth, they are found in a molecule with 2 of them together. They are, let me put them all in here for you. They are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So although you can find one hydrogen when it's in a compound with something else, like hydrochloric acid, which is HCl, if you ever have hydrogen by itself, it has to be H2. It is not stable enough to exist by itself just as hydrogen. Nitrogen is not stable enough to exist just as N. You would find that in nature as N2, and so on. Now you have to know these 7. Okay, you have to be able, because one of the questions on your test could say which of the following is a diatomic element or which of the following is not a diatomic element. So you need to be familiar with these 7. The way that I teach my students to remember that is by knowing the term heavenly 7, because again there are 7 of them, and all you have to do is look on the periodic table. The H is where the heavenly comes from. Okay, that's why we say that, to remind ourselves that the hydrogen is in there also. And then you draw a 7 starting at element 7. Okay, again, draw a 7 starting at element 7. So watch me do that here. Okay, I just drew a 7 starting at element 7. So it's hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Nitrogen is element 7. Again, it's hydrogen because of the heavenly part, and then I draw a 7 starting at element 7. Again, those 7 molecules those 7 elements are the elements that are not stable in nature by themselves. They have to be with something else. Okay, and then the last bonding basics thing that we need to cover is single, double, and triple bonds. Single look like that, double look like that, and then triple, which are not very common, look like the one on the end there. Now, what we need to know about single, double, and triple bonds is their size and their strength. So you need to know that single, let me get this written in here, single bonds are the longest and they are the weakest. Okay, and you can almost think of the bonds as like a magnet. So if you just had one, they wouldn't be held very close together. If you had 3, these are the shortest and the strongest. So if I draw out a molecule that looks like this, and you have to pick for me, I want you to pick the strongest bond, and that would be your triple bond right there. If I asked you to pick one of the weakest bonds, you could pick any of those other single bonds. So any one of those, any of those. Okay, so you need to know that single bonds are the longest and the weakest, and that triple bonds are the shortest and the strongest. The other way that you will see this represented on your midterm is that you need to know that if something is the strongest, then it's going to take the most energy to break. And you can even think about this if you try to do this with your fingers. If you hold your hands together with one finger from each hand, that would be pretty easy for somebody to break. If you held your hands together by 3 fingers on each of your hands, then you're going to be a lot stronger and it takes a lot more energy to break. So you need to know that in order to break a bond, it takes energy, and that the stronger the bond, the more energy it takes to do so. So again, that's all for this presentation. I know that it does seem a little bit scattered, but again, I took everything from the bonding units and picked all of the other stuff that you hadn't covered yet that will show up on your midterm.